Hi everyone, welcome to the RisingWave channel. In this video, we're excited to show you a practical demonstration of how RisingWave can be used for real-time traffic flow prediction. Predicting traffic flow isn't a new concept. It's already a crucial part of modern navigation systems and traffic light management in many cities. But the real magic behind any successful machine learning application like this lies in its ability to process and learn from incredibly fresh, constantly updated data. This is where RisingWave comes in. In this demo, we'll highlight RisingWave's strength in real-time feature engineering, showing you how it can continuously extract valuable insights from live data streams. Here's a quick look at the data flow for our demo. As you can see, data moves through 5 main stages, from the initial capture by sensors and cameras to the final visualization. At the heart of this entire process, you'll find RisingWave, acting as the central data hub. Now, let's get started and build this out. Step 1 is all about getting our data into RisingWave. We need to feed it the raw data captured by cameras and ground sensors. For this demo, we'll use a Python script to simulate these data sources. The script sends this information into Kafka, and RisingWave then ingests it directly from there. We'll set up 2 source tables, one for camera data, including things like vehicle type and license plate, and another for sensor data, which captures the speed of passing vehicles. With our data flowing in, we're ready for step 2, where the real-time magic happens. We'll use one of RisingWave's core features, materialized views, to transform this raw data into meaningful features for our model. Think of a materialized view as a smart, self-updating table. It continuously and efficiently calculates our key metrics as new data arrives. For traffic prediction, we're most interested in 2 features: the total number of vehicles per minute and their average speed. We'll use RisingWave's built-in time window functions to group our streaming data into 1-minute blocks and calculate these 2 features for each road. This gives our prediction model a clean, up-to-the-minute view of the traffic conditions. Before we get to the predictions, let's take a quick look at what we've built so far using Apache Superset tool. I'll start the data generation script now, and you can see the simulated data appearing here in the terminal. First, let's check our raw data streams in Superset. As you can see, a steady stream of data is coming in every second from Kafka and being stored by RisingWave. Now, let's look at our features. With our materialized views, we can have a clean table showing the 2 features we care about: vehicle count and average speed, neatly calculated for each road every single minute. Now for the exciting part. Step 3, making predictions. We'll feed these real-time features into a pre-trained machine learning model. For this demo, we're using an LSTM model, which is great for understanding patterns over time. First, we use the RisingWave SDK to pull the latest features from our materialized view. The model needs the data in a specific format to make a prediction. Specifically, it looks at the traffic patterns from the last 5 minutes to predict the next minute. So we'll do a quick transformation to normalize the data and shape it correctly for the model's input. Once the data is in the right format, we feed it to the model and it gives us a prediction. The model we're using was built with TensorFlow and has already been trained on a large data set from California's highway network, so it's quite accurate right out of the box. After getting a prediction, our next step is to store it. We'll save the prediction result right back into RisingWave alongside the feature data that was used to generate it. This creates a complete record, making it easy to display and analyze later. Let's run our prediction script. You can see in the console that we're generating a new prediction every minute and saving it. If we go back to Superset, we can see our predictions appearing in the traffic flow table. And as we let it run, this table will continue to fill up with fresh results. Now we've made it to the final step, visualizing our results. Data is most powerful when you can see it clearly, so we've built a real-time dashboard. This dashboard is designed for someone like a traffic operator who needs to monitor road conditions at a glance. To make this happen, a backend script reads the latest data from RisingWave and pushes it to the web interface in real time. And to enable the front-end page to receive data from Kafka, we need to use a WebSocket connection.
Here is the demonstration of our demo. On this dashboard, you can see the current traffic volume and average speed for each road, and the predicted traffic for the next minute is displayed right below it. Every minute, the dashboard automatically refreshes with the latest information. We've also added a simple rule. If the traffic volume goes above 40 vehicles, the number turns red, flagging potential congestion. If you want to dive deeper, you can click on any road to see its traffic data from the last 3 hours. We display this both as a table and as a line chart. In the chart, you can see 2 lines, one for the actual traffic and one for our predictions. Notice how closely the 2 lines follow each other. This shows that our real-time prediction system is not only fast, but also highly accurate.
And that wraps up our demo. We've shown how you can build a powerful end-to-end real-time prediction application with RisingWave at its core, from ingesting raw data and performing real-time feature engineering to serving a live dashboard.
Thank you so much for watching. We hope this gives you a good idea of what's possible with RisingWave.